all of you are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Tree Level. So in this video, we are going to move ahead and talk about a little bit about multi-threading models. So some operating systems provide a combination of user level and kernel level thread facility. And Solaris is actually a very good example of this combined approach. In this combined system, what happens is that multiple threads within the same application can run in parallel on multiple processes, and a blocking system call need not actually block the entire process. So the multi-threading models can be of three types. So it can be, remember that first it's user space and then it's kernel space. So to map both of them, we have three multi-threading models. The first one is the many-to-one multi-threading model, then one-to-one and many-to-many. So let's quickly take a look at what these models really are. So first we'll talk about the many-to-one model over here. So what happens in the many-to-one model, many user level threads are mapped to a single kernel thread. Okay, and thread management is actually handled by the thread library only, which we've already talked about earlier in the previous video about what it is. So thread management is handled by the thread library only in the user space, which is efficient very well. And in this case, if the user level thread libraries are implemented in the operating system in some way that the system does not support them, then kernel threads use this many-to-one relationship model. So here, since we are mapping the user level threads to the kernel threads, if somehow the user level thread libraries are implemented in the operating system, right, that the system does not support, then the kernel level threads use this many-to-one relationship model. Okay, so here we are mapping the user level threads to the kernel level threads. Okay, here what happens is only one thread, okay, can access the kernel at a time. Okay, so multiple threads right here are unable to run in parallel on multi-processors. Okay, since here only one thread is accessing the kernel at a time, multiple threads cannot run. Okay, that is what the overall idea is whenever we talk about this multi-threading model over here. Okay, the disadvantage of model is that since there is only one kernel level thread, right, the point that we discussed earlier is just a disadvantage, right? This model can, because this is many-to-one, kernel user level threads are mapped to a single kernel level thread, right? This model cannot take advantage of the hardware acceleration that can be done by multi-threaded processors. Okay, here the thread management is done in the user space only using the thread libraries. Okay, so that's what the overall idea is about this many-to-one model over here. Next, what we have is the one-to-one model. In the one-to-one model, we create a separate kernel thread to handle each and every user thread. Okay, most implementation of this model actually place a limit on actually how many threads you can create, because the more threads you create, the more kernel threads would be required to map them. Okay, Linux and Windows from 95 to XP actually implement the one-to-one model for threads. Okay, and this model provides more concurrency compared to that many-to-one model. Okay, this model, like I said, maps a single thread to a single kernel level thread. Okay, and this kind of a model facilitates the I would say the property that you can run multiple threads in parallel. Okay, however, this benefit comes with a drawback. Okay, so whenever you create a new user thread, okay, the generation of every new user thread must include a corresponding kernel thread, which is like an overhead. So sometimes you have, for every user thread, you have a kernel thread that can help you to achieve parallelism. But since you have to correspondingly every time map a kernel thread for a user thread, right, it kind of becomes an overhead, okay, which can sometimes hinder the performance of a parent process. Okay, that is why we saw that Linux and Windows implement this model, and they constantly try to tackle this problem also by providing a limit to the growth of the thread count. Okay, that is what is basically the one-to-one model over here. Okay, next what we have is the many-to-many model. So what happens in this many-to-many model is it basically multiplexes any number of user threads, okay, onto a equal or smaller number of kernel threads. So it's like a many-to-many. You can map any number of user threads to equal or less number of kernel threads, combining the features of one-to-one model also and many-to-one model as well. Okay, user can create as many number of user threads they want, right? And here the blocking the kernel system calls also does not block the entire process. Okay, and the processes can actually split across multiple processor. Okay, so what we discussed about many-to-many model is that in many-to-many model there are several user level threads and several kernel level threads. Okay, the number of kernel level threads that you have can actually depend on the particular application. Okay, the developer can create as many threads as they want, okay, at both the levels, but they may or may not be the same. Okay, the many-to-many model is actually a compromise, or I would say a hybridness of the many-to-one and the one-to-one model. Okay, and as we saw over here in this point, that if any blocking call is made by a thread, okay, the kernel can immediately schedule another thread for execution. So it does not block the entire process. Also, with the introduction of multiple threads, complexity is not present as it was in the previous models. Okay, although this model does provide the capability of creating multiple kernel threads, true concurrency also cannot be achieved by this model. Okay, this is because kernel can only schedule one process at a time. Okay, so this is what our many-to-many model is. Okay, so I hope this is clear to everyone. This was a very short discussion and a very simplistic overview as well. When you have a many-to-one model, you are mapping a large number of user threads to a single kernel thread. When you have a one-to-one model, you are basically mapping a one user with one kernel. And when you have a many-to-many model, a large amount of user threads can map to equal or less number of kernel threads. Okay. So each of the models have their own advantage or disadvantage. For any, I would say, systems that implement these models, they have their own pros and cons that they try to tackle with. Okay, but with this, I hope the entire series of threads is clear to everyone. This was our last video on the thread module, and I hope you understood each and every part of it. Thread these days form a very important part of your entire working and development cycle. And it's very important that you have a good grasp on these topics as they help to build the underlying idea when you're trying to scale applications and build and work on multi-threading and multi-processing applications. Okay, so with that in mind, I hope I was helpful in creating this journey a little bit easier for all of you, and you are able to understand each and every aspect of threading, right? And I really hope to meet you all soon in the very next module that we are going to start. Till then, keep practicing. Thank you.